In this video, I want to show some of the interesting mathematical property of Bitcoin price. It's something that I have been interested for many years, and I have posted in different places on the internet my analysis. Um, I have been a scientist for almost 30 years now, and I have analyzed many different mathematical systems, and I took an interest in Bitcoin for many different reasons, for its decentralized properties, for the philosophy behind it. But being a mathematician and a physicist, I almost immediately noticed that Bitcoin price didn't seem random like many financial assets, but had a particular um, precise behavior that I recognize from studying other interesting systems in science, from astrophysics to neuroscience, um, to many different type of systems that I have worked on professionally over the years, and I have I've been shown these in different mathematical analysis in on Facebook. I didn't write so far a professional article. I intend to eventually, but I've done some analysis with when I posted in on social media. This is the price of Bitcoin. If it is plotted in a linear chart, right? So on the y-axis we see the price in dollars. These are the days, and I'm choosing as time zero being the time when Bitcoin was created. It's very difficult to get data points in the particular year when it was created, because most of the transactions didn't have really a price associated with it. Were mostly done between Satoshi and people in his network. Finally, we got some data point. There is the famous purchase of pizza in Jacksonville, and there were other few transactions that I was able to find on some archives online, and I'm going to show them later, and I actually included in the model. But here, the price of Bitcoin was initially in the first several hundred days. It was so small in comparison with the price right now that it looks like basically it is flat, right? And then looking at this chart, it doesn't look there is anything uh, precise or a precise pattern, right? It looks like yeah, there are some peaks when there are these local bubbles, these crazy peaks in 2017. Many people criticize my graph, saying, "Oh, I should put dates." That is true, but I like to see numbers, for my days, so I have a sense of the scales of time that we're dealing with. Um, but basically, this is the peak when we reach um, basically almost $20,000 value for Bitcoin. Um, and then there was a long bear market. There was a crash, and we went back almost all the way to $300 from sorry, $3,000, from almost 20,000, right, from 20,000 to $3,000 when we had this bottom here in this bear market. And then Bitcoin price recovered. There was another peak here, about $12,000. I think this happened last summer, so almost 1 year ago. Then again, some fluctuation, and now we see the price going up again. So it doesn't look like there is any specific particular pattern, but one of the things. I want to show you this. This was one of my early posts when I started to see some. This was early 2000. See here in the recent chart, we are dealing with three, almost 3,800 days since Bitcoin was created, and we are dealing with few thousand. So we are talking about. I think this post was like 2012, if I remember well. Um, but I was already finding some regularity. Like in this case, for example, if you plotted the price on a log chart, that is something that people do often when you see an asset that changes over several time scales. Like we went from uh, Bitcoin be worth less than $1, like just a few cents, over thousands of dollars. So we're talking about almost 3 orders of magnitude. So it's very common in science to plot any type of phenomenon that covers many orders of magnitudes over a log scale. So it's easy to see the changes and how they relate to each other. And also, what was clear to me that these times when Bitcoin fluctuates so much, the so-called bubbles, actually follow. We have some very precise periodicities, that they seem kind of clear to me, even when we have just few of them. And so I made some kind of prediction. I didn't have enough data. I didn't see the entire behavior. At the time, it seemed kind of exponential. So if you here, for example, I was trying to fit it with a straight line on a log graph. The model, it was not a simple exponential model. It was actually more complicated. Basically, I explained it here in the post. I was trying to find some kind of a relationship between the number of users that they could be modeled by looking at the number of wallets, that is kind of a proxy for the real number of users, and then using kind of a logistic model. The logistic model, it's kind of looks like an S. Basically, it grows very slowly initially, then it has an exponential growth, very very fast growth, and then it saturates and it flattens out. And it's something that is not random in terms of trying to model something like Bitcoin, because it's basically the adoption, what is called the adoption curve of the adoption model. So basically, there is some early enthusiasm for some kind of technology. Many technology, in particular digital technology, follow this kind of pattern. So there are some early adopter, and in that case, the growth, they could be basically the number of people that are using the system. Um, and I can show you something, adoption curve. If I can spell it right, this one. Yeah, so right, so this S curve, and this other graph is, this red curve is the distribution. So basically, how many people are are using the system. It could be a particular innovation, a technology. So Bitcoin, it looked to me like it was not a normal asset, but a technology that people were going to adopt and use with time. Um, Other network properties, because people were sharing it and sharing the information about the existence of Bitcoin, but also exchanging it. So it was not going to behave like a normal asset. Was going to behave more like the adoption curve of technology. So in this early model, um, I was trying to model Bitcoin using some kind of curve like this. So if you look actually, a curve like this initially will look like an exponential growth, right? So very, very slowly in the beginning, very, very fast. But then, it saturates. So there is actually a mathematical formula that gives you the S shape, but initially will look like an exponential, and if you graph it in a log graph, it's going to look like a straight line. So this is what I had in mind. It's a very nice model because, and I'm still working on a model like this because basically all what you need to know really, it has only one frame parameter, but it is basically how many people at the end are going to use the system. And you can do different assumptions. You can say, okay, maybe 1% of the entire population of the world is going to use Bitcoin at its biggest expansion, many years from now, maybe 10%. And you can actually determine different scenarios. You can say, okay, if this happens, 10%, we will get this. If only 1% will adopt at its maximum, right? When it saturates of a world will adopt Bitcoin, then this other scenario is likely. So you can have you cannot predict exactly what is going to happen, but you can have a range of scenarios. So I work on this model. The most interesting piece of this model was that at that time, actually, I found a relationship between the number of users and the price. So it seemed to me that there was a very precise relationship. It's called the power law. There was if you plot the number of users versus the price, was a very strong correlation between the two. I will discuss this model and an updated version um, in another video. But this was one of my early work, um, and I was still missing a piece because as I was following the price over time, the price started to deviate from this exponential behavior by a lot. So sometimes that happens, and in physics, what we say that there are phase transitions. So it look almost to me that some kind of phase transition, like at a certain point the behavior changes, so you need to fit the new behavior with another straight line on a log graph. It seemed, doing that seemed very complicated. And then finally, it came to me. I also was, to be completely honest, I was prompted by a friend of mine that posted a model that made some kind of a model that made some kind of sorry, I'm trying to move this window. Okay. Yes, there was something like that that a friend of mine showed me that somebody was plotting um, after we started to have a lot of data, started to plot again the same thing, um, the price on a log chart, log on the y-axis, um, linear um, time on the x-axis, and as we started to collect more data, the price of Bitcoin looked still pretty regular, but it was not a straight line. So if it is a straight line on a log chart, it means on a simple log chart where you have only log of the price, not the log of time, let's say. In that case, if you see a straight line, you're dealing with an exponential model. But if you see a curve, it could be many different things. It's not clear. But this friend of mine did some analysis, and he was thinking that maybe we're dealing with a power load. This is what he claimed. And I was very familiar with power laws. Because it's something that occurs very often in physical systems. And I will discuss that again in another video in more details, what is the significance and relevance of that. It's something that, just to give you a feeling, it's very universal. Many systems that grow from to be small things to large things, like for example a river that starts like a small stream of water, and then over the millions of years becomes a river with a lot of affluents and so on. These systems, cities, many different type of structures, and both natural and human made, follow some very precise mathematical growth pattern. And one of the best way to show the presence of these systems, if you have data, from, let's say, historical data of how the river was formed, or maybe historical data about the growth of a city, or other information about the system from its covering many the different scales that describe the system, maybe in time, but also in its like, for example, I could measure the typical length of a tree, has its branches off, like its trunk, then it's different branches, smaller branches, and so on. If I have this information about spatial information or time information about the system, I can plot it in a graph, and maybe I plot one type of information on the x-axis, like if it is time, for example, the time, how the system grows in time, and then its size on the y-axis, and then the idea is to plot it in a log, what is called a log plot. So I have the log of the price and the log of the other quantity. In this case, we're analyzing Bitcoin price, the log of time. So we start here from numbers that are above zero, right? So we're talking about so this is the log 10 of time measured in days. So 10 to the 3, for example, will be 1,000 days, so about 3 years after Bitcoin was created. And like I say, there are not many data points. This basically is one of the earliest data points that I could find that is reliable. There are few data points I will show you in another graph that have to do with pre-market. Basically, this is when the first markets that traded Bitcoin publicly opened. So we have reliable data. We can look at few other transactions here, but they are sporadic. We have only few recorded public transactions before this time. But we can still adjust the scale, saying, okay, if Bitcoin was created at a particular date, then how many days are passed since that time, right? And the Genesis block for Bitcoin is January 3rd, 2009. This is when Bitcoin was created, so we can calculate the time that is passed by and then adjust the scale accordingly. Um, and what was striking to me when I did this exercise, um, that gave me some new information, from the previous models that I was using to understand Bitcoin behavior, is that now that mess that I showed you in the beginning, the price not following a precise pattern like this one, right? If you show this chart to the average person, say, yeah, okay, maybe there is a general trend to go up. It goes up and down, but now it's much higher than what it was several years ago. But there is nothing predictable there, right? It does whatever it wants. But when you look at chart like this, and if you have any interest in math and physics, you almost recognize immediately these patterns that are called power laws, because power laws show up as a straight line, and it's a very simple mathematical thing. I mean, I could derive it for you, and maybe we can do that as an exercise another time. But and there are probably many, no, there is much information online that can show you why we have a power line. Sorry, we have a straight line if you're dealing with a power law. But basically, the idea of power law, and here basically I'm trying to describe with a formula how a power law looks like, right? So basically, the price it's some kind of depends on time, and it depends on time. So t is time here, t minus 1 is the time since moment 0, basically the genesis block. Basically, the time is related to price by a power. So like you're raising to the power. Like let's say, for example, this alpha could be square, right? Any power, 3 or whatever. So the price grows as a so if it was a square, for example, I double the time, and the price will go up by a factor of 4, right? I triple the time from the beginning, the price will go up 9 times. But any relationship, and this A is just a constant, right? It relates with two quantities, right? To make the model complete, you will need some kind of constant there, and it's a relatively simple thing to show that this is what you will get. You will get a straight line, right? If you plot the log of a price versus the log of a time, then this relationship is going to be a straight line in this type of graph. And this is one of the tests that in physics we do all the time when we are trying to understand the behavior of physical system. First we plot in a linear chart, we see if there is a simple linear relationship, then in a what is called a log linear chart, like the log in the y-axis and linear in the x-axis. And if we don't see straight line, why straight lines? Straight lines are easy for the human eyes and for human mind to comprehend, so we recognize very easily this relationship when we see them. And so it's kind of, there are of course more sophisticated tests that we can do to show, it kind of approximate a straight line and so on. But it's nice to see this visually, that over so many orders of magnitude, we are talking about Bitcoin being a fraction of a dollar, so a few cents, all the way to tens of thousands of dollars. So it's basically 5 orders of magnitude And when you have a phenomena that over 5 orders of magnitude behaves in a very regular fashion like this, where it grows in a more or linear way, when plotted on a log-log graph, you're dealing with something that is not random. It follows very precise mathematical processes. These are most mathematicians, physicists are trained to see this phenomena. Now, of course, it's not a perfect line. There are these huge, big oscillations. The price can deviate a lot. So this red line represents, so it's one of these actually mathematical methods that I use. It's a regression. There is a calculation that you can use. You calculate what is called the best fitting line. So it's basically a line that is minimizing the distance of each single point from the line. There's a mathematical procedure to calculate that, and that procedure also gives you quantity that is this r square, and an interpretation of this number that is in this case 0.93. It's basically how much of a behavior of these price in this case, right, can be. Let me explain better. So. Modeling this strange behavior, right, that goes up and down with a straight line, it's not perfect, but if you do that, this straight line explains basically 93% of the behavior. Everything else is noise, right? It's 7% variation and noise around the straight line. 93% is explained by this straight line. So this very simplistic model of a straight line in a log-log graph that is actually a power law explains 90% of it, 93% of the data. There is debate. I debated this with different people. There were some criticism about this model. People say that this regression calculation cannot really be done when you have something that behaves like this, but we could go for hours discussing this. I think it's silly because it's a rough calculation. Nobody's saying that we're dealing exactly with a power law, right? That is the real phenomena behind is a power law. It's just a lot of the behavior of Bitcoin can be explained as a power law. There are other behaviors like the bubbles that probably are more complex. We're still dealing with the financial systems that are not even something complex like the creation of a river is still due to very deterministic physical laws, that look random to us simply because there are so many things happening at once that there is a lot of randomness, there is a lot of noise, but in the end it's physics. We're dealing with a financial phenomena that maybe is more regular than other financial phenomena, but it has still a lot of complexity that we can explain away with a simple model like this. But the fact that we are getting an R square that is so close, so basically the idea, right, if this number was 1, it will mean we explain 100% of the behavior of Bitcoin with this model. In fact, we are very close, so 0.93 is very close to 1. It means that it has a lot of predictive power, it has a lot of explanatory power. And you could have come up with this model very early on, like you could have done this 1 year ago, 2 years ago. And I tried, right, because I started to make similar model to this early. It's just that we didn't have enough data, not enough magnitudes, scales of magnitude to actually be certain or that we're dealing with one single unique model that could explain the behavior over all these uh, magnitude scales, different scales. So now that we have almost 12 years of data, it seems to me that um, it's still a probably approximation of a real behavior, but it's a very useful model that tell us that Bitcoin will continue to go up. That is the main conclusion of this model, that Bitcoin is growing and it will continue to grow, and it grows at a predictable rate. I actually started to publish this model in media, probably when, for sure, after the collapse, just after the collapse, right? This collapse from the big bubble of 2017, and so we are talking about now more than 1 year, and my prediction was exactly this. And you can see that even if there are oscillation, the price is still following this red curve, and it will continue. It will continue for the next year. Now, how long it can continue? This model is not a logistic model. It doesn't contains this flattening of the curve, and we need to include it somehow. So it's just an approximation. My because we don't see any large deviations, or we don't see a breaking down of this particular pattern, not at this point. We will see if it was the case. There are other tests that we can do. For example, we can measure how stable these constants are. This alpha, that is the power. By the way, the power is close to 6. So basically, I don't know if I can do a power of 6 in my head, but basically you can use a calculator, right? You double the price, you take the power of 6 and see what that gives you, and triple and take the power of 6 and so on. But basically, so it's very fast growth. But one of the things that happens when if you see this behavior that is a power law behavior, is that oh, sorry, I'm drawing. So let's go back to yeah. So if we instead of plotting the price in a log chart, we plot it in a semi-log chart. It's called log linear or semi-log. So basically, we only have log in the y-axis versus the and the linear in the x-axis. Then what you see is this curvature, right? And so it looks like it's kind of flattening. It's not going to flatten ever if we just use this model. So we need to add some additional pieces to kind of explain a saturation at a certain point. But even as it is, it shows that as Bitcoin grows, the growth is still very strong, but because we are dealing with a system that is bigger and bigger, right? We're not talking about going from a value of few dollars, for example, to hundreds of dollars, to thousands of dollars. We're talking about going from tens of thousands of dollars to maybe hundreds of thousands of dollars, or even millions of dollars. The system takes longer and longer time. So if you look at now a linear time, you see, for example, you can use the not just the bubbles, seems to happen at further and further times apart from each other. But the general growth of the price, it's actually slowing down. It's slowing down relatively to these scales, right? So if you're talking about how long it's going to take for Bitcoin to go up by a factor of 10, if you look at the time that it took uh, when we were going from, let's say, $1. So this zero means $1. Um, so when we went to go from $1 to $10, the time was very short. You can see, very short. When it took longer time to go from $1 to $100, from even more longer time from $100 to $1,000, and here, for example, and it will take even longer time, right? Take even longer time to go from $1,000 to $10,000, and even longer time to go from $10,000 to $100,000. We're still going there, and I think it is going to reach that, but it's going to take many years from now. So, for example, $100,000 here. If we use this model as a way of predicting the price when that price is going to be reached. So right now we are here. It's going to take about other 3 years. So we are kind of a year 12 now. We're going to reach 100,000 in 3 years from now. Now, it's possible that we have a bubble, and in that bubble, the price goes very far away from the general trend. So the general trend is this red line, and in that case, the price goes up, maybe even reaching 100,000. The point is also the bubble. So if you look at the bubble, so I model also the bubble, and the blue line is supposed to be a model for the bubble, some kind of periodic behavior. It's called a log periodic. So it's basically it's a sine wave that has a log in the argument. So if you plot it again in a log graph, see if I have that here. If you plot that in a log graph, the bubbles seem very periodic, right? So it looks like a sine wave. There is no perfect alignment between the peak of this bubble, this model, and again, it's just an approximation. But when you plot it in a log plot, the general trend looks like a straight line. The bubbles look like a sine wave. But then when you go to a log graph, a simple log graph, you're going to see that the bubbles take longer and longer time. So it's almost like a sine wave. It becomes, as a wavelength, so it becomes bigger and bigger. The period of oscillations became longer. So if you model that, and the dotted line is supposed to be kind of a projection of that, we are going to have a bubble also about 3 or 4 years from now. So probably the price will not reach $100,000 until then. That is longer than some of the other models, some of the models that have been there, like for example, the stock to flow model, that is the most popularized model at this particular time. Now there is some debate, and I added this discussion online. I will go more in details in other videos. If this power law model, it's an approximation of a stock to flow model. The stock to flow model, it's a good model, mostly because it has some kind of explanatory power in it, in the sense that it tries to find some relationship, between quantities that have some kind of financial meaning, but it makes a lot of assumption too. While this model, it's all empirical, right? You have a bunch of data, you're trying to fit with what seems the best simple mathematical model that can explain a lot of the behavior of a price, and then you make some predictions, okay? And so far the predictions have been holding pretty well, and if anything, this model is it's kind of conservative. And so, while, for example, the stock to flow model actually predicts that we are going to reach $100,000 earlier than these dates that I'm using here, 3 years from now, let's say. Yeah, so far it's holding very well. It has a lot of explanatory model, has explanatory power. It's, at a certain point I will make a video why power laws are so universal, are so interesting. So there is some appeal in that sense. That there is some reason why Bitcoin is growing in this way. Now, the stock to flow model simply says, oh, it's part of how Bitcoin is designed, is due to the halving, and that um, if you actually derive equations of what to expect, and again, the same friend of mine that helped me understand how that Bitcoin was a power law also wrote an article. I will give you some references later. Um, Actually deriving a more formal equation for the stock to flow model, and you can see how the power law model that I'm describing here could be kind of an approximation of that general formula, but we don't know, right? We need more data to actually be sure of which model actually Bitcoin is following. Right now, I still like this particular model, not because I came up with, or I was one of the first people to point it out, but because it's basically it's an empirical model. It's based on data. Now, one of the nice things I was telling you before that I found a few transactions that were available. You can find them online, the time and the price before markets open. And these basically are these purple dots here. This particular dot here is actually the pizza event. It's interesting because with these other two earlier transactions, people that bought Bitcoin at some kind of um, public sale and uh, uh, and some other early transaction. I don't remember exactly. One can research them, but they do seem to follow retroactively, right? So if you go back and fit it all the way to the Genesis block, this two data point fits actually pretty nicely the curve, while this guy is kind of an outlier, and it looks like it was a bad deal even at that time. Even if you say, well, Bitcoin was not worth it a lot, it was the model tell us that actually he should have sold this Bitcoin. Now he could have bought much more pizza. In other words, but it is what it is, and it's an historical event. It's interesting. Um, but so this is a um, some of the points I wanted to make about this model. Some people sometimes tell me, well, what is the usefulness of this, right? Even if we do this exercise, how that helps us, like, for example, if we wanted to invest in Bitcoin. The first thing, the biggest important thing is, if you think that Bitcoin is going to crash to zero, it's not going to happen. Now, we never know because, again, we're not dealing with a physical system that is going to do certain things in a certain way, and you can kind of count on that. A war can happen, many disastrous events can happen. Yes, Bitcoin, like any other asset, could go literally to zero. But if things are more or less like they are, and we are going through a lot of different things. We are going through the COVID crisis. We have been events like China banning Bitcoin. Many different things. And Bitcoin, yes, locally it responds to things like that. Maybe there is a bubble, maybe there is a crash, but in general, it's doing its own thing. It kind of doesn't care, really doesn't care, right? Bitcoin is the budget of money, and this is one of the reasons. Now, why it's doing that? Because it's programmed to do that, because it's a network and there's robustness in it. I don't know, and we could maybe explore that, but if you base your analysis on data and nothing else, But it's one of the things that kind of I like. I am experimental physicist. I like to think about the theory behind, but in the end, I like to base my analysis on what is really happening. Then this is what you can derive since it's birth basically. Even these few little data points are now. These are it's kind of silly because it's just few data points, so they don't have a lot of statistical power. But when you look at the entire picture, it looks like there is a very precise behavior. So you can extrapolate that if Bitcoin has done this for the last 12 years, it's going to do this for the next 3. So if one of your objectives, let's say, is, oh, I'm going to invest now when Bitcoin is $10,000, will it reach 100,000? So I multiply my money by 10 in few years. Yeah, it's going to happen. That you can statistically, right? So you make a bet, like in any investment, and your bet is very strong, that it's going to reach this kind of prices, because they will continue to do this thing. There are many different forces that act on this system to keep it down, to maybe explode, but it's going to take its time, and it's going to reach to these prices. This is one of the things we do in physics and mathematics. And again, even if the market or assets, financial assets, are not physical systems, they share a lot of properties with them. And so you have to understand it's all this is it's in a statistical sense instead of a more deterministic sense, but it's a very good bet. The other thing that you can do also, you can identify periods that are bull periods, and in fact periods that are crazy, and they are, basically you can tell by using a graph like this when Bitcoin is overbought, like during this frenzy in 2017. At that time I didn't have this model. I was still relying on some of the older models. I was a little confused. I was still trying to understand what was going on with Bitcoin. But if I had a chart like this, I will have immediately identified, and I will have sold my Bitcoin, because it was evident, it was clear that this behavior could not be sustained, and Bitcoin was going to crash. Now, the precise time that when it's going to crash is not easy to determine, but on a certain point you could have decided, okay, I'm getting out. I'm waiting for Bitcoin to get back to its original path, and then I will buy again. And if you have done that, you could have made a lot of money. And again, we can use this chart for things like that. Right now, even if it seems it gained a lot relatively to recent times, it's actually undervalued. If we zoom here, if you look at where the price is relatively to its trend, it's below. So anytime that the price is below the red line, the price is undervalued. Anytime it's above, we are overvaluing Bitcoin, and you can still hold on it, but if the deviation is too big, and now how big the deviation is, we can discuss in another video, then it's probably time to sell. And if you do this, you actually have a trading system. So you can buy Bitcoin, sell Bitcoin, and you don't need for Bitcoin to reach 100,000. You can make a lot of money just doing that. And I will make another video explaining some of the strategies and how we can do that. Just to give you a feeling, here one of the things that you can do, it's to determine in a chart like this what is kind of the bottom line. So Bitcoin seems to have reached points. This is it's not like people draw arbitrary lines on financial graphs, and I always hated that. And this is not what I'm doing here. I'm using actually some mathematical formula to say, okay, what are the statistical deviation of Bitcoin relatively to its price? It seems that when it reaches a bottom, it's always consistent, like here. And when it reaches as a peak, is also consistent. up to a point, right? For example, these two data points. So it seems, for example, that the peak of a bubble, it's kind of in a downtrend, but you can still measure the deviation from the trend. This is the orange line here. You can say, okay, it's a very large deviation. Maybe it's time for me to sell. And there are other things that you can do to actually use mathematics, to determine when it's time to buy, when it's time to sell, and we can discuss this in another video. Thank you to follow me, and for your patience to put up with my explanation. Thank you.